Hello and welcome to part 1 of lesson 4, linkages and parametric design. In this part we will be talking about what are linkages, and then my creation of linkage plates, and then in the next part we'll be talking about using those linkage plates in a model, and then we'll also talk about some parametric design, which is how linkages work, but briefly. So what we'll cover: what are linkages in general, then why did I make these linkage plates, and what are their capabilities? So first of all, you need to know what a linkage is, and a linkage is a combination of parts mechanically connected that will transfer motion. So a really good example of this would be a scissor lift, or such as this crank right here. It's a good visual aid. So why did I create these linkage plates? Well, first you have to understand that there are some problems with the current existing systems for building robots, because this is derived from robotics. So first of all, there are no good ways of doing linkages. If you look at this Tetrix robot right over here, you see that there are these very large metal pieces with very tiny screws connecting them, and there's no good way of adapting those for something like this, where you want a long, thin piece with easily accessible or points for rotation. And even these, which are long and thin, don't have good ways of attaching together to make a linkage, and they're heavy. Additionally, scaling is a big problem. Sometimes you want to have a big robot, sometimes you want to have a small robot, and it can be difficult to take that mechanism you've made on a small scale or large scale and transfer it over. So these linkage plates allow for easy scaling, because they can scale to any size, as well as CAD integration. Many of these components, while they're getting better, are not easily accessible in CAD software, and it can be really hard to have an idea of what is going on in your robot if you don't have it modeled in CAD. As well as, if you just look at this, this is a screenshot of the file with all of the parts in it from the Tetrix directory. It's a mess, and I can't tell what's going on. Oof, okay. So, what would be ideal in a good system? So it needs to be easily able to be modified. So you need to be able to take it, and if you want to add, say, I have a plate and I want to add a claw to the plate, you should be able to add a claw. Then you should also be able to easily incorporate it into any existing things. So if you have this really cool arm, but it doesn't fit on anything, it doesn't do you much good. As well, it should be easy to produce and simple. So if you have a massive learning curve on the coolest thing in the world, and it takes you a year to master, or even a year to learn how to use, that's a year you could have spent making a lot of progress on something simple. So that brings us to linkage plates, which is my solution to these problems. So they were really inspired by the mechanical sculptures by J.K. Brickworks, as seen here. It was so cool, these Lego sculptures that these guys create. And I wanted to take my own hand at that. Additionally, I think I'll show it. These are also fully parametric, so every single dimension can change. So from the holes to the number of holes to the width, height, depth, everything is fully parametric. But I have also stripped it down a little bit. So although you can change anything, there's a more easily accessible version if you don't want to have all those options overwhelm you. Going with that, it can accommodate any existing system, such as Tetrix, Acrobotics, Rev, Lego, and all the others, because every dimension can change, so it can fit to anything. And additionally, you can scale it. So if you make a tiny mechanism with the linkage plates, you can change a few values, and then now it's big, but it's the same mechanism. It should work exactly the same. It's pretty cool. And lastly, they're easy to produce, because they are flat with holes in them. Relatively simple. You can do that on a CNC, a laser cutter, or a 3D printer. Although laser cutting and CNC is probably better for this. So here's a model by J.K. Brickworks. So cool. It moves. Here was sort of my inspiration. You can see it in CAD that I wanted to create a mechanical sculpture so the bird rocks back and forth and the butterfly flaps up and down. Some of the parts are hidden in this picture to save on resources. Same here. So linkage plates. So like I said, they are fully parametric and any dimension can change, which means they can accommodate any existing system such as Tetrix, so you can fit these, which is what the original robot at the beginning was made out of, or Rev, these. Both of these systems don't have linkages, but now you have access to them. And they'll be super easy to produce. And yeah, so let's take a look. So in the next part, we'll be talking about using these linkage plates in assemblies and how you can move them around, as well as customizing them to different sizes. Thank you and farewell.